So what we're doing here is basically making machines that turn air into oxygen. And who needs these machines are people who have lung diseases, their breathing is compromised so that they don't get enough oxygen throughout their body, and it makes them lightheaded and can be dangerous. So the things that are done on the market already are they use a pressure change, so they take the air and they pressurize it, and that way they can extract the oxygen. However, we're going with a new material. This material works by a change in temperature, not a change in pressure. So now we can remove the compressors, pressure vessels, heat exchangers, all the heavy components of devices which are called portable oxygen concentrators. We can get rid of all the heavy mechanical components and replace them with a single powder, a nano powder, which works by changing temperature. So at 20 degrees room temperature, you can walk around, it'll intake the air around you, and it will naturally bind the oxygen. So once we want to release the oxygen so that the user can get it, we increase the temperature to roughly 60 degrees, and that would be sufficient to release all the bound oxygen and thereby concentrating it for the user. We threw together this prototype demo recently, and what it does is basically this powder that works with the temperature change goes inside this column where we're flowing air through. Once the material which is inside is saturated with oxygen, then we begin heating. You can see there are some heating coils inside. They heat the material and then the oxygen is released. It's rerouted through our device and fills up our a balloon, which someday can represent a patient. So now, in order for it to operate continuously, this column needs to be replaced by, we need to add another one in tandem. So you can imagine one is absorbing oxygen, one is releasing oxygen. So this one can be cold, this one is hot. Once this one's depleted, then we flip it around. Now this one was full and it can begin desorbing the oxygen while this one is refilling with the oxygen. So the performance metrics that we need to meet in order to be smaller, people are having trouble carrying heavier devices, so the idea is that we're smaller. 6 pounds is very light compared to 10 to 20 pound devices which operate by the pressure change technology. And the real key here is that we also need to last a long time. The changing temperature is much more energy efficient than powering a compressor in order to change the pressure. But we still need to flow the same amount of oxygen so that those who are prescribed with 2 liters per minute can still get that 2 liters per minute. But now what our device is capable of doing is also being flexible. So instead of a rigid device that you need to carry around with you or wheel around with you, you can now wear it like an armband or a vest or a pocket protector, anything. It's flexible, it's fluid. So the fact of the matter, why we come in and why we're new, is when we turn the materials that exist. So these oxygen-sensitive materials have existed for quite some time. Nobody has applied nanotechnology to this field yet. So the idea of nanotechnology is to reduce the particle size and make this temperature change smaller so that our power requirements are reduced. That way you don't need to carry around a heavy battery, which basically defeats the purpose. So in our efforts, we've proven that reducing the size of the particles reduces, it actually increases the oxygen capacity and the rate that you desorb and absorb oxygen. Now, that corresponds to lighter and more efficient devices, and basically we want people to not have to carry around something so heavy and obtrusive that it really kills their whole freedom, and now people will be able to walk around with something that's so natural, feels like clothing, and they're still getting that oxygen that they require.